How do I see the future of blue biotechnologies? For us, it will clearly involve a new generation of EPS, transformed by cutting-edge technologies, of course, and some of them will be surely vectorized.
On the other hand, one thing won't change, and that is the naturality. Local sourcing, low energy transformation process, and above all, EPS that respects all ecosystems.
Whether this is the planet ecosystem or, of course, the skin ecosystem. Indeed, EPS are extremely beneficial for the skin flora. They are molecules produced by marine planktonic microorganisms. But do you know the percentage of similarities between the bacterial plankton and the human microbiota?
73%. 73% similarity. In fact, these marine EPS are simply postbiotics.
A very interesting discovery was that EPS are not only beneficial for the balance of skin microbiota, they are also able to reinforce innate immunity.
This means two things. One, they provide a very effective way to reinforce the overall protection of the skin. Then, they are capable of activating biological pathways.
The diversity of the biological pathways activated by EPS is equivalent to the diversity of the EPS themselves. This is something that we clearly understood in 2015 with a project called Polymer.
Polymer is a collaborative project between university and private companies. The purpose of the project was to be able to characterize our EPS and understand how they are able to interact with biological pathways. We have discovered EPS structures that has never been described before. Huge molecules of roughly 1.5 million Daltons are able to fold up to form glycovesicles and to reach receptors located in the deepest layer of the epidermis.
These studies completely changed our views about EPS. Before this, EPS were mainly known for their surface properties, such as immediate smoothing action and mattifying or antifouling effect.
Actually, in 2011, Cody's enthusiasm for EPS was based on several criteria such as their original surface properties and the fact that they are unique molecules, fully qualifiable and naturally biodegradable.
This is for all these reasons that Codif has decided to commit alongside Polymeris. Because it was obvious that these molecules were completely new and unique.
Why unique? EPS are sugar polymers which are extracted by microorganisms either to fix a substrate, protect themselves, or communicate with each other. Each microorganism synthesizes a specific ExoPolySaccharide. Each EPS is therefore unique not only on its composition but also on its configuration.
It is here that Polymeris has positioned itself as a pioneer in understanding the world of EPS. Between 2008 and 2010, they collected 700 different marine microorganisms
with their isolate profile and screened. Result? 40 different EPS were discovered and registered in a private collection at the Pasteur Institute.
And the great thing about the story is that they did not have to go and look for this microorganism in extreme environment. They went to look for them in their immediate environment, the Brittany coast in France. Why?
And why not? Brittany offers more than 3,500 kilometers of coastline, with an enormous biodiversity as the region is swept by the current of the Atlantic Ocean and the Channel. And also because 97% of our planet's biodiversity is found in the ocean, and only 1% of marine biodiversity have been identified.
So imagine yourself in their place, anchored at the tip of Brittany with your eyes looking up towards the ocean. What do you see?
A huge potential for innovation. This is where it all started. This is where it all starts.